Welcome back to Daily LeetCode. It is day 105. We're doing an early session today, so I'm glad to see that is back in the rotation. However, the ship is falling apart. The HCC needs you. If you haven't yet, you're going to want to join the HCC Discord because we need you now. But yeah, we're doing a shorter session today, so about 45 minutes. So I'm just going to talk for a few minutes, but yeah, I'm realizing now as I stack more on top of the ship, it becomes even more the requirements. I guess the requirements for, let's just say, the ship's durability, its velocity, the amount of what it can carry, the people who are on the ship, becomes like very, very, very crucial. So I guess the analogy would be that the weight that I'm trying to put on the ship is everything that I'm trying to do, and the ship, I guess, itself is like a function of me, things that are going on in my life, how my goals are set up, my objective, how I'm going about it, the way it's structured, and yeah, I'm realizing that the more I add, the tighter the ship has to be, and since the ship has to be like tighter run, then the marker point for instability is higher because there's less room for error, which is very interesting. All this to say, doing weekly contests yesterday, 311, and it was just a bloodbath. Yeah, sometimes it's just a bad session, but it's also, I think, about thinking about why it was a bad session. It was a bad session because I just did a lot that day, and the session was at the end of the day. That's why we do it in the morning. At the same time, right now, I'm also out of brain juice, and the day just started. So while I don't perceive that things will have changed today, I'm also realizing that it's what I said earlier, basically. So the sleep schedule, basically, things got messed up. I slept at the usual time, and I woke up at the usual time, but I woke up like 3 or 4 times throughout the night for some reason. So now my head is just messed up. It feels like I'm in the Twilight Zone. So yeah, it's just, and yeah, I did I think it was yesterday, we did like an hour, and then after work, no, yeah, we didn't actually have any time pre-work yesterday, so I did everything after work, and so I think I spent let me see, it's like 4 hours, 3 or 4 hours, I don't know, but doing the sessions back to back like that did not help, and then actually made it, there's just a lot in there, because if you focus too much before sleep, then actually it's harder to sleep. So I read like a system design book before I sleep. I mean, not a system design, software architecture book. It's called like the philosophy of software or something like that. That messes me up. So I think the only way I think this works is a split. If I could break it up into 2 sprints, one in the morning and then one after work, things would be perfect. But solving the morning puzzle is still a work in progress. I can get up at a certain time, but I need to be able to get out of bed sooner. So yeah, it's just tough. We really need to figure it out. So yeah, I'm gonna be doing another. I'm gonna try and finish a little bit more time into the weekly contest. It's what the goal is for today. So, but yeah, make sure to join the HCC. Yeah, and if you have any ideas on how do you stick with your schedule, I'd be interested to hear it. I'm also interested to see if anyone else does a weekly contest. So I know Thomas does it, and I know we just started doing it, so I'd be interested to know. And I have to remember that next week I have to make sure I do the weekly contest at the allotted time, so I don't do it late again. But yeah, or our time frame on these on all this is just messed up. So maybe that's the missing piece of the puzzle. If we could make this, it's sustainable. I just need to find a way to add some consistency into it, so that the routine stays the routine. But that being said, we're going to jump into the problem we left off on yesterday, which was admittedly impossible. I'm not convinced it has been solved before. But yeah, so I'm just going to jump into the session today. So you have longest subarray with maximum bitwise AND. You are given an integer array nums of size n. Consider a non-empty subarray from nums. is the maximum possible bitwise AND. In other words, let k be the maximum value of the bitwise AND of any subarray of nums. Then only subarrays with the bitwise AND. In other words, let k be the maximum value of the bitwise AND of any subarray of nums. Return the length of the longest such subarray. Bitwise AND of an array is bitwise AND of all the numbers in it. A subarray is a contiguous sequence of elements within an array. So in example 1, right, k would be the non-empty array such that the bitwise AND of its subarray is the longest such subarray. Maximum possible bitwise AND of a subarray is 3. Longest subarray with that value is 4. Maximum possible bitwise AND of a subarray. Longest subarray with that value is 4. So maybe we are wrong in that this could be a sliding window problem. Maybe the way we're going about it is wrong. Maybe what we need is two approaches. One approach is sliding window. The other approach is two-step. Find largest bitwise AND. Then find longest array of that value. But when I think of the sliding window, I feel like it maps perfectly here. What we're trying to maximize is a subarray with the largest bitwise AND, which is no different than maximizing for a subarray with the largest sum, maybe. One, two, three, three, two, two. We did before. Take the bitwise AND. It's easier to just restart with 3. So we do that. Say we start at 1. Then we take the bitwise AND of both. We get 1. Then we say we continue to take the bitwise of 3, or just restart with 3. So we choose to restart with 3. Longest subarray with maximum bitwise and. So it looks like secretly in this problem, you can either maximize. I think you can either maximize for the size of the bitwise and, the maximum possible bitwise and, or the longest subarray. For example, in the example, there's an example where they have 100, 5, 5. If you want the maximum possible bitwise and, you have to choose 100 and it's 1. But if you want the longest array, it's 5, 5. I've been doing longest array, and I think we should be doing largest number. And I'm also not convinced that we need to use bitwise as a value here, because it always seems like if you do and, you always lose value. Is there a solution? Is there a time where you do bitwise and you don't lose value when the numbers are the same? If you do 10 and 5, you get 10 is represented by 8 and 2. And 5 is represented by 4 and 1. So you just get 0, I think. So I think the thing is you have to be greater than the max num. If you're greater than or less than the max number, then we want to restart. Otherwise, it'd mean you're equal to it. So let's say if num equals max num. Else we don't want to update max num. Well, actually, yeah, if max num, when max num will get the value of, if num is actually greater than max num, then we'll set it to num, or we'll set it equal to num. Otherwise, we want it to keep its value of max num. So let's see if this makes sense. For 1, 2, 3, 3, 2, max num is going to be 1. Okay. And then we're going to start at 2. We're going to say, is 2 greater than 1? I mean, is 1. The way we have it set up too, instead of saying num, let's just call it cur num. So cur num, which is 2, and max num, which is 1. So does 2 equal 1? No. So we're going to restart with cur length equal 1. Now max num, is cur num, which is 1, greater than max num? Yes, 2 is greater than 1, so we'll set it equal. Max num will now be 2. And cur and max will both be 1. We go to next number 3. Does 3 does 2 equal 3? No. So we're going to restart with 3. We'll set cur length equal to 1. Then we're going to say max num is equal to, is 3 greater than 2? Yes, so max num gets set to 3. And we're going to be at 1. Now we're going to say, okay, now we're at the next 3. Does 3 equal 3? Yes. So cur length plus equals 1. We have 2. Max length is now 2. Now we're going to be at 2. Is max num, which is 3, equal to 2? No. So you go to else, we're going to restart, and then we're going to say, is 3 greater than 2? Is 2 greater than 3? No, so we're going to keep max num at 3. So this should give us the correct value for 1. Does give us 2. Let's try the rest of the test cases. So they expected 9. Oh, they expected 1, and we gave them 9. Oh, I see. We're taking the longest, we're keeping the longest array. We want the longest array with the largest value. We want to maximize for the largest value first, which is why it would be 1. So I think we just have to change this line here, right? If cur num is actually greater than max num, we want to say max length equals 1, because we'd like to restart with this number's value because it's the greatest number we've found so far. And we'd also like to say max num equals cur num. So then we would have 1, 2, 6. So we're outputting 1, 2, 6, which is 1 more than we should be outputting. So the last 3 all equal 1. For some reason, we're off by 1. Why would we be off by 1? It looks like all these values are the same. Let's see if we can duplicate this issue. Yeah, I'm not understanding. Maybe it's after a long run. No, it looks like the whole array is this number. Actually, no, it doesn't. Let's just say we have something like this. Why would this case be failing? Oh, what if it's equal? Right. It's greater than, or it was equal to max, and we also want to restart there too. Output is 126. Why are we getting one more though? In most cases, it seems like we don't have an extra one. And in a particular case, we have an extra. Actually, it doesn't actually make sense for equals to be here. why would this be off by 1? You know what? Let me do a puts just to see where I'm at. We'll do cur num. So is it when we start? Ah, I see. Say cur length equals 2. When we start 586730 for the first time, we don't reset back to 1. At least maybe? Cur length equals 2. I think I get it. I think I see why this is happening. We find our max earlier, then we run into it again. Let me see if this is why it's not working. I think it's because we find our max num sooner, and then when we come back to it later on, we're off by 1. So yes, our answer is 12, and the expected answer is 11 now. So I think we can make this much smaller. I think we just need 1, 3, 2, 3, 3. Right. So we get 1 max num. We find our max earlier. When we get to 2, right, we say, yeah, we're at 2, right? Our cur length is equal to 1. Then we go to 3 and we say, okay, does maximum equal cur num? Yes. So we add 1 to it. But it doesn't exactly make sense because we should have restarted once we got to 3. Now the question is that the problem in the if or the else? We're saying cur length equals 1. Cur num, which is 2, is not greater than 3, so max length now equals 1, max num equals. Then we go to 3. I think this whole thing would be simpler if we just did the step-based version. I think we're trying to combine them earlier on. So let's just get it right first. The maximum possible bitwise AND of a subarray is 4. This is just taking the maximum value in the array. What is going on? Get maximum value of array. My camera's been big the whole time. Yeah, today we're just off today. Today's, oh man, I didn't even realize. Ugh. Maximum value of array. Get longest array of this value. And then we'll just say nums dot each do we know the max value exists, so we know that the max length, at least at minimum, has to be 1. And so we'll do the same thing we did before. We'll have a cur length, which is also go to 0. And I think we just need to know the pre num, which we'll set to float of infinity, then we can just say if the current number equals the max value, right? That's great. It means we want to update we want to change the current length. Now, how we change current length will depend on if prevnum equals max value. If prevnum equals max value, it means we just want to add curlength plus 1. Now, if the prev number is not the same as the max value, we're going to set it equal to 1 because it'll be the first time that we're seeing it. Say max len equals per lane max len dot max. And then at the end of the loop, we want to say prev num equals num. Then we can return max length. So to do this, we'll get the maximum number in the array, which is 3, right? And we're going to say, okay, we're going to start at 1, right? Does 1 equal 3? No. Max length is either going to be 1 or 0 is going to be 1 because we know at least one number exists of the max value. Prev num now equals 1. Now we're going to be at 2. Does 2 equal 3? No. Prev num is going to be 2. Does 3 equal 3? Yes. Now does prev num equal 3? No. So we're going to set cur length equal to 1. Max length is going to be max of cur length or max length. Prev num is going to be equal to 3. Now I'm going to say, does 3 equal 3? Yes. And does prev num equal max value? Yes. So we're going to do cur length plus 1 equal cur length. So we're going to have a cur length of 2. And the max length of 2. And prev num is still going to be 3. We're going to go to 2. And we're going to say, does 2 equal 3? No. Now prev num is going to be equal to 2. So I think it should work with the example test cases. And then let's try the one earlier that was messing us up. So basically, we find the correct answer here should be 2. But when we find our value early on, and then later on we come back to it, we're off by 1. No. Say it ain't so. Oh my god. I'm wondering if we just sometimes I think what's the retro on this? Did I jump too fast on a pattern? Did I jump in too fast on a pattern? Or I think it is, and I think maybe that's part of the idea of encoding knowledge through practice. I thought this was a sliding window pattern problem, but when I see sliding window and I try it usually works. There is some aspect or attribute of this problem which makes it not, or at least I believe not, a typical sliding window problem, which is why there was difficulty encoding the problem as such. Either way, I think ideally there would be a way that I can hone in on those specific aspects and see why it wasn't a sliding window problem. And I think I figured out what those aspects are. I think maybe there were 2 things we were trying to optimize for, and we were trying to do that within the sliding window loop, which is why when we went for the max value side, we got different issues. But when we went to the max length side, we got different issues. And then we split the steps up completely. I think it's still a sliding window problem. Except the work necessary for it has been done outside the loop. So maybe that's the takeaway. Maybe the takeaway is you can sometimes do work outside the loop to simplify the sliding window. So let's go with that and see if it helps us or hurts us in the future. Nums at each.2 equals max underscore value current length prev num. I think the other thing I realized in this problem is that there has to be some reframing. I took the problem as bitwise and I ran for it. I didn't read it close enough because they're clearly denoting a stepwise process down here. I think maybe another thing to consider is the order of things to try. If they're giving me a stepwise approach to solving the problem like they did here, like maximum possible bitwise and of a subarray is 4, and the longest subarray with that value is 4, then I should just do that. And then try my own approach. But I don't want to focus too much on the words of the problem. I'd rather focus on the output. Because the words tend to be quite tricky. Like they're asking for bitwise and, but they're really just asking for the largest value in the array and then the length of the longest subarray of that largest value. But either way, I think that we'll count that. And yeah, I don't know why I made the video so large, but we're gonna try and finish the rest of them. Find all good indices is also a medium. You're given a 0 indexed integer array. We only have a few minutes, so I'll just read it for today. Given a 0 indexed integer array nums of size n and a positive integer k. So 0 indexed array, positive k. We call an index I in the range. K is less than or equal to I. Call an index I in the range. K is less than or equal to I. Less than n minus k. Good if the following conditions are satisfied. The k elements, so k has to be less than I, but I has to be less than n minus k. Good if the following conditions are satisfied. K elements that are just before the index I are non-increasing order, so they're in decreasing order, and the k elements that are just after the index I are in non-decreasing order. So we're going to find return an array of all good indices sorted in increasing order. So if an indice, if the k elements before an indice are in decreasing order, and the k elements after are in increasing order, if there are 2 good indices in this array, for example 1, doesn't quite make sense. 2 good indices in your index 2 subarray, non-increasing means decreasing. Oh, it's in decreasing in respect to where it starts. That's true. And the subarray 1 and the subarray 1, 3 is in non-decreasing order. Oh, so 1, 2 is going down. 2, 1 is going down, and 1, 3 is going up, starting from the indice where it starts at. So we're going to wrap up for today, and yeah.